Let's sketch the graph using 5 major points. Say we have y equals sine of 2x minus pi. I'm going to set up some ordered pairs using those 5 major points. I'm going to start by separating this in half. You'll see why in just a few minutes. So the first column is going to be what x is going to end up being. The second one is going to be the 2x minus pi. Okay, so 2x minus pi, those are the inputs, so I'm going to use my 5 major x values for that. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when I go to find the sine of each of those values, these are going to be the outputs. So this is going to be the sine of 2x minus pi. In other words, the sine of 0, which is 0. Okay, sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. So then in this fourth column, I'm going to write down the ordered pairs, which are going to be x, comma y. So I still haven't found what x is yet. I have 2x minus pi. So now at this point, I need to figure out what is x. So when 2x minus pi is 0, so when 2x minus pi is 0, solving for x, I would get pi over 2. So when x is pi over 2, the output is going to be 0. Okay, when 2x minus pi is pi over 2, solving for x, I would add pi, so 2x, add a pi, we get 3 pi over 2. So then dividing by 2, x is 3 pi over 4. Okay, so then the ordered pair is 3 pi over 4, comma 1. A few more here. 2x minus pi is pi. So adding pi, that means that 2x is 2 pi. So x is pi. Okay, so when x is pi, the output is going to be 0. Okay, 2x minus pi is 3 pi over 2. So adding pi, we get 5 pi over 2. Divide by 2, and we get 5 pi over 4. Okay, with an output of negative 1. One more, when 2x minus pi is 2 pi. That means that 2x is 3 pi. So x is 3 pi over 2 with an output of 0. Okay, so now I'm going to plot these 5 ordered pairs. Okay, since the first x-coordinate is positive, I'll put the y-axis on the far left. So 0. The first x-coordinate was pi over 2. The next one is 3 pi over 4. So I only added a quarter of a pi. So since this is a half of a pi, let me mark out where the quarter is. So now I'm just going to go a quarter of a pi to get to the next x. Okay, and then another quarter, another quarter, another quarter. So pi over 2 followed by 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2. So those are my x-coordinates that have been spaced out appropriately. The next I need is the y. Highest value is 1. Pi is about 3.14-ish, so when I divide that by 2, this is about 1.5. So a little lower than that is going to be a 1. Okay, so at pi over 2 we have 0, and then it just follows the pattern of sine, up, down, down, up. Okay, now if we look back at the original sine curve, that would usually start at 0, 0. So this is y equals 2x, sine of 2x minus pi. Usually we would start at 0. So that's where sine of x would start. So notice that we have a movement to the right of pi over 2. So this is what's called a phase shift, because the x-coordinate moved over pi over 2. So we have a phase shift of pi over 2. Okay, so now we can add in a new generalization here. So this was 2x minus pi, so we have an a in front of sine, we have a b in front of x, and now we have a new variable, let's call that c. So when y is equal to a sine bx minus c, the amplitude is still the absolute value of a. The period is the original period of sine, which is 2 pi, divided by whatever's in front of x. Make sure that's positive though, so absolute value. And then now we're adding in what's called a phase shift, which ended up being pi over 2. The original function was sine of 2x minus pi. If I were to pull the 2 out of the 2x minus pi, I would be left with x minus pi over 2. So this pi over 2, this was the phase shift. Another way that this could have been found was taking 2x minus pi. If I set that back to the original input of 0, then x is pi over 2. So in other words, if I want to find the phase shift, set bx minus c to 0, and x would equal c over b.